Hi everyone, my name is James and today I'm going to show you how to do problem number 63. Two objects are connected by a light string passing over a light frictionless pulley as shown in the figure. The 5 kilogram object is released from rest at a point 4 meters above the floor. A. Determine the speed of each object when the two pass each other. B. Determine the speed of each object at the moment the 5 kilogram object hits the floor. And C. How much higher does the 3 kilogram object travel after the 5 kilogram object hits the floor? Let's just start this problem by drawing the diagram. Alright, let's start with A. A wants us to determine the speed of each object when the two pass each other. So what they mean by that is, this 5 kilogram block is 4 meters above the ground and this is at the floor. And before we start with A, since these two objects are connected by the same string, and since you know that this is 5 kilograms and this is 3 kilograms, you know that if you release this system from rest, this block will go down and the 3 kilogram block will go up because this is heavier. And since they're connected by the same string, if this goes down by a certain velocity, this will go up by the same velocity. Same with acceleration. If this accelerates downwards at some acceleration, it will be the same here. That's because they're connected by the same string. Now back to A, when they want to know the speed when they pass each other. So just when they pass each other, it will be at 2 meters, because as this goes down, this will go up. It will be exactly 2 meters. So in order to solve for the speed, we can just do a set of kinematics. Let's write our givens. Since you're releasing the system from rest, your initial velocity will be 0 meters per second. You're solving for your final. You don't need acceleration, but you know that your displacement is 2 meters and time, we have no idea. So how do you get your acceleration? You can get your acceleration by summing your forces in the y direction for both of these blocks, setting up a system of equations, and solving for acceleration that way. I'll show you how to do that. So let's sum up our forces in the y direction of the 3 kilogram object. Your positive forces will always be in the direction of motion, and since this block is going up, the positive motion is actually tension minus the weight, and that'll give you the mass times acceleration. So that's for the 3 kilogram block. 45 kilogram block, since it's going down, this is your positive force. So you're going to take 5g minus the tension equals 5 kilograms times the acceleration. As you can see, this sets up really nicely to just for elimination. This is what it will look like. Equals 5a, tension minus 3g equals 3a. I just reordered it a little bit and I moved this down here. I'm setting up a system of equations to solve for A. The tensions will cancel out when you add them together. So you will get 8a equals 2g. And A equals, your acceleration equals 2g divided by 8 equals 9.8 meters per second squared. This will give you 2.45 meters per second squared. You can put that acceleration back up here. And now you can solve for your final velocity. You can look at your kinematic sheet to get the equation, but it is final velocity squared equals your initial velocity squared, which is nothing because your initial is 0, plus 2ax. You're going to need to square root it. And if you plug everything in, you will get 3.13 meters per second. So that is for A, when the two blocks pass each other, both will be moving at 3.13 meters per second. Now B wants to know, determine the speed of each object at the moment the 5 kilogram object hits the floor. In order to do this, you can just set up another set of kinematics, because when the 5 kilogram object hits the floor, basically your displacement is just 4 meters now. So let's just set that up and get that going. Again, since you are releasing this system from rest, your initial velocity will be 0. And you know acceleration now because you solved for it. So you can put that here as 2.45 meters per second squared. And now you know that your displacement is 4 meters. Now you can look at your kinematic sheet and get the equation, but once you do that, you'll get something like final velocity squared, square root 2. Again, you can find the formula on your sheet and solve it, but this is your answer basically. 4.43 meters per second. So when this 5 kilogram block travels 4 meters and finally hits the ground, it will be moving at 4.43 meters per second just before it hits the ground. Now let's do C. C wants to know how much higher does the 3 kilogram object travel after the 5 kilogram object hits the floor. This one is a little bit tricky. Well, not tricky, but there's a little bit of a concept behind it. And to demonstrate this, I'll be using this iPhone wire here. As you can see, I have this iPhone wire here. Now let's pretend that I'm going to try and mimic the diagram here. This is your 5 kilogram block, and this is your 3 kilogram block. I'm sorry, other way around. This is your 5 kilogram block, and this is your 3 kilogram block. If you look at the diagram, 3 kilogram block is on the ground, 5 kilogram block is a little bit off. So when the 5 kilogram block, when you release it from rest, it's going to drop to the ground. So what happens is, when it drops to the ground, as you can see, the 3 kilogram block jumps up a bit. They want you to find a maximum height. In an ideal world, or more, you might not think about it. When the 5 kilogram block drops slowly, let's say like that, you would think that you're just measuring the height from the ground to where it came up, but you actually have to measure the little bounce that it gets when the 5 kilogram block just drops, because while it's traveling up, it still has some of that kinetic energy. So that kinetic energy gets transferred a little bit, and I'll give it a little bounce. I'll show you, all right? It bounces a bit. One more time. It has a little bounce to it. So the maximum height will be from the ground all the way up plus that bounce. So let's get back to the problem. So how do you solve for that bounce? Well, I'm just gonna draw the diagram as if the 5 kilogram block is now on the ground. So here's the pulley. The only difference in the diagram now is that the 5 kilogram block is now on the ground. And this is the 3 kilogram block. So at the very top of this block's bounce, when it reaches its maximum height, all right, I'm going to draw another picture to show the little bounce. All right, it's going to look something like that, like this string kind of bends up, and this is at its maximum height. You can see it's a little bit higher than here, because once this drops, it's not going to look like this. It's for a split second, it will look exactly like this, because it will just bounce up because the kinetic energy is still going. And at the very top of its trajectory, right here, it only has gravitational potential energy. But at the very instant that it's here, just right before it goes up for the bounce, it will have kinetic energy because it's still traveling. So that means you can set these two energies equal to each other, since the energy is not lost yet, because you're not calculating after it falls down, you're calculating at the very top, so the energies are equal. So you can call this energy A, or you can call it point A, point B, and set the energies equal to each other. So since this is your kinetic energy, you have 1/2 mv squared equals your gravitational potential energy, which is mgh, and you're just solving for h. And what this h is actually that little bounce that you get. That is your h. So you're just gonna isolate you're gonna isolate your height, and that will give you, well, first you can cancel out the masses. You will get this. And once you plug everything in, plug in 4.43 meters per second. Don't plug in that one because that's only at the 2 meter mark. This is at the 4 meter mark when this block has completely fallen to the ground. So make sure you use 4.43 here. 4.43 meters per second squared over 2g. And you will get height equals 1 meter. All right. Okay, so if you're still not convinced about that, I'm going to share one last time a little bit clearer view. So your 5 kilogram block is in the air and your 3 kilogram block is on the ground. So your 5 kilogram block is of course heavier than your 3 kilogram block. So if I release this from rest, this is going to go down and you will see that this will bounce up. Alright, 3, 2, 1. Okay, it does bounce up and you need to account for that. Again, 3, 2, 1. There. So that's the bounce, and that bounce happens to be 1 meter.